Hello everyone, it's Miss Thomas, and today we're going to look at applications of exponential functions. As a reminder, for y equals ab to the x, a is the initial amount, b is the growth or decay rate, x is the independent variable, and y is the dependent variable. For the growth and decay rate, something you really need to know though, typically it's 1 plus r or 1 minus r. This would be for growth, and this would be for decay. And the r needs to be written as a decimal. So our first example, the number of bacteria in a culture, n, has been modeled by the exponential function n of t is equal to 1200 times 1.148 to the power of t, where t is greater than 0, and it's measured in days. So we want to find the initial number of bacteria in the culture. So if we're looking for the initial amount is your a in y equals a b to the x. So the a is the number being multiplied by the base. That would be the 1200. So the initial amount would be 1200 bacteria. How many bacteria will be there after 5 days? So this time we're going to find n of 5. So it's 1200 times 1.148 to the 5th power. So remember your order of operations, you want to make sure you raise that 1.148 to the 5th power first. And it's 1.99. A couple more decimals. I'm just going to hit times the 1200. And my n of 5, my number at 5 days is going to be 2392.7. So in this last question, how long will it take for the number of bacteria to reach 5,000? So this is something actually that we're going to look at a lot in class. So what we would do here, we actually want to solve this by graphing. How long will it take for the number of bacteria to reach 5,000? This is the number of bacteria. This is actually what your n is. So for n of t equals 1200 times 1.148. We don't know our t in this equation, which is pretty tricky. We don't know how to get an exponent out of the, or a variable out of the exponent. It's going to be 5,000. So what we're actually going to do is we're going to graph in our graphing calculators tomorrow. We're going to make our y1 5,000. We're going to make our y2 the function. And we're going to actually graph both of those, and we're going to find where those two intersect. So the graph of those functions this is going to look something like this when we graph it. We don't care what it is on the negatives because we can't have negative bacteria. And then the 5,000, y equals 5,000 is going to cut through like this. And what we're looking for is this point right here where they intersect. I'm going to show you tomorrow how to do this on our calculator. I'm going to do that right now. So when I solve it on my calculator, I get that the point of intersection is 10.3, and then the y is 5,000, which I already knew. So it's asking how long until it reaches 5,000. So my answer is really going to be my x, because my x represents my time. So it will reach 5,000 on the 10th day. So I actually want you to try this one. This is n equals 1,000 times 2, and I'm going to write it over here. N equals 1,000 times 2 to the 0.01 t. I want you to find the initial number of bacteria in the culture and also find the number of bacteria after 3 days. Okay, so go ahead and try that, and I'll see you tomorrow in class.